Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about Leetcode question number 78, subsets. Given an integer array nums of unique elements, return all possible subset, the power set. The solution set must not contain duplicate subsets, return the solution in any order. So since they have given the unique elements, it is sure that we don't get the duplicate subset, right? Okay. And for this question, we can do in two approaches. One is a bit manipulation approach, that is a binary approach, and another one is a backtracking approach. Let us see the two approaches, but in this part 1 video, we are only going to see about the bit manipulation approach, that is a binary approach. Fine. First of all, you want to know about what is meant by subset, right? Okay, see here, if 1, 2, 3 is my original array, let's say it is an original array, then if I delete this 1, what is my array looks like? My array looks like 2 and 3. Okay, if I delete this 2, what my array looks like? Something like 1 and 3. If I delete this 3, my array looks like 2, 1, 2. And if I delete 2, 1, my array looks like 1. And I can say 2, then I can say 3, then I can say 1, 2, 3. And I can say empty if I delete all elements. So this is what they are asking us. Okay, this is what they are asking us. Fine. So a subset is formed when we delete one or more element from that array. That's the definition of subset. And the important note for the subset is we cannot reorder. We cannot reorder. Okay, don't do this anything. We cannot write like 2 1, or we cannot write 3 2 1. These are wrong. We should write in order. Fine. Hope you understand now. Yes. Fine. Now, how can I approach this problem? Fine. Just see here. It is n is equal to 3, right? The length of this array is 3. Okay. How many possible combinations I get? I got 8 possible combinations. So I can say if I give n is equal to 3, I get 8 combinations. So definitely for n elements, I'm going to get what? 2 power n. Okay, let me write here. For n elements, I want to get 2 power n possibilities. Okay, so this is gonna be my hint. Now, how can I do this? Just see here. Let me take an example. This is an example. Just see this carefully. I will write 0 to the 2 power n minus 1 elements. Sorry, that count. Okay, 0, 1, 2, 3, 4, 5, 6, 7, up to 7. Because 2 power 3 is what? It is 8 minus 1 is equal to 7. Because this input size is what? 3. Fine. Now, just look at this array. It is what? 1, 2, 3. Fine. Now, the binary representation for this 0 is 0, 0, 0, which means if I put 0 in this 1, then this 1 is deleted. I can say this 1 is deleted. That's my representation. Now, it's all 0. That means this all are deleted. If these are all deleted, what is my array? This array is empty. Okay. Now, if I delete first two elements, then what is my answer? It will be 3. Similarly, I done like this. Hope you understand, right? See this example, it will be more clear. Now, this is what the first approach. This is my approach number 1. In this part 1, we are only solving this approach. Okay. Now it's time to see the code because it is enough, right? Okay. Let us see the code. See here, this is the code. First of all, result is equal to empty list. Now n is equal to 2 power that len of nums, and I'm just traversing to what? That up to n, 0 to n, which means 0 to n minus 1, 0 to 7. If I give 8, sorry, if I have n value as 8. Okay. Now result dot append of binary of I, which means this binary of I is a function I'm going to write, which gives me, if I return 1, then it will give the appropriate that subset, like that. See here. If I give this 1, it will return what? 3. If I give this 2, it will return what? 2. Like that. It will send the appropriate, but I made a little change. Instead of this 3, it returned what? 1. I will tell you why I done it. Okay. Let me select this and rerun it so that it will be more clear. Just take for example, if a number maybe something like 6. Okay. Now it comes here. What is my num? My num is what? 1, 2, 3. It is 0, 1, 2. Okay. Now, if num and 1 is equal to 1, whether it is 1, see here, It is what? Num. Don't confuse. This is what? Nums. This is what? Array. This is what? Number. Don't confuse. Don't confuse. He just gave the same identifier with yes. Okay. Don't confuse. Don't confuse. Now, this is nums. Let me write it so that it is more clear. Now, num and 1 is equal to 1. Okay. What is the binary representation of 6? It will be 1, 1, 0, right? Okay. If I do AND operation with this 1, now you get what? 0, right? These are 0. This 1 and 0 will give 0, and these are will be 0. So it will be 0, right? So it won't execute. And again I will do what? Num is equal to num right shift 1. If I do right shift 1, it becomes something like 1, 1. Yes. Again loops comes. Now I value is what? Initially 0. Now I value is what? 1. Fine. Again go. Now num and 1 is equal to 1. Whether 1 and yes, it is 1, right? It is 1. So auxiliary dot append of nums of I. What is nums of I? Percentage. What is that percentage? Percentage is 0. Sorry, 2. So auxiliary will be now 2. Right. Now again num is equal to num right shift 1. If I do again right shift 1, it will be only 1, and will be 1 again. Yes. Now whether num and 1 is equal to 1. Yes. Now I value will be 2, and yes. Now it goes here auxiliary dot append of nums of I. So nums of 2. What is that? Second it is 3. So 3 will be appended. Fine. So it returns what? 2, 3. But here it returns what? 1, 2. So this is what I have told you. Here we wrote like this, but in real time it returns what? This 1, like this. It is for your basic understanding. But in real time we can implement in any ways, right? You can also implement it like this. We can reverse it at last. You can also implement it. I will also show you that code at last. But still, you want to know this. This is easy to write, right? That's why I wrote it. Okay, now it's time to see the time constant and space const. What is the time constant? It will be O of 2 power n, because we are traversing up to what? 2 power n in the loop, right? Now 2 power n. Okay, now into n. Why this n, you may ask? Because we are just doing what? We are just inserting this to the result, right? We are just inserting to this result. So it is not a constant operation. Yes. So that's why it is into n. Okay, what is the space const? It is O of n. N. Yes, because we are using this aux, right? This aux will leaves the space, and we don't take that resultant. Resultant array we don't take. Okay, fine. So this is all about this approach. Now it's time to see the code. So this is the same code I already explained. Okay, fine. Let me submit it. Yes, it is submitted successfully. Now it's time to see the next code. Okay, so see here, this is like that previous code I written, right? See here, I will traverse from for I in range of len of nums minus 1, minus 1, minus 1, which means what? I'm traversing from backward. I'm traversing backward. So let me take this code snippet. Okay, just see here. If I give 1, 2, 3, fine. Now at first it comes to here. Let us take that same 6. What is the binary representation of 6? 1, 1, 0. Now it comes here. Now it will be like, currently my I is there at 3. Now I'm doing and 1. It will be like 0, 0, 0. So it is 0. So it not gets executed, and nums will be reduced. Now nums will be reduced to what? 1, 1. Right? Num will be reduced. Now again this num comes here. Again my I will be now where? This 2. Now again I'm doing AND operation. Now it will be 1. It will be 1, right? So it enters here, and it does just take that into auxiliary. So auxiliary will contain what? It contains 2, right? 2. Okay. Now again it is reduced. Again it is 1. Then doing AND, it will be 1. So now my I is here. So 1 is taken and 1 is written here. Now I will reverse it. So it becomes what? 1 and 2, and I will return it. So this is for reversing. You may do the reversing like taking the first value and last value, reversing, then swapping, that approach, but I am just done the slicing approach here. Okay, so this is how we will do. If I say if I do like I said in the previous at the starting point. Okay, see here I haven't reversed, but here I done a reverse. That's it all about. Okay, let me just do that. Let me submit it. Yes, it is submitted successfully. Thank you.